I'm Nicholas, and this is Josh, and we're from Anaconda. We're going to be quick because I know we're running out of time, but if you do have any questions, please find us afterwards. We're happy to tell you about that. We're going to tell you a little bit about some research and development and a work in progress. So what we're showing is currently unfinished, but we do have a live demo because we're idiots, and we'll just see what happens. Anyway, we want to get to the live demo as quickly as possible. So... Who are we?
So this is me when I was 12 years old, and if you believe the internet, I am still 12 years old. And I have spent the past 9 years focusing on block-based educational projects.
And my name's Nicholas. This is me in my natural habitat. I'm actually a classically trained musician and spend most of my time thinking, I wonder how long it'll take people to realize I'm just a musician, not actually a coder. So I'm mostly self-taught. Well, there are only 10 orchestras in the UK, and there's only one tuba in each orchestra, so you do the maths. So it wasn't a great career choice, so I became a teacher. So for most of my 20s, I was in music education, and nobody told me the dress code for the school, wear a necktie.
So this is my project called EduBlocks, and I started this 9 years ago when I was a high school student because I realized that there was a need for a tool that sat in between block-based programming and text-based programming. So the basic concept is that it's drag-and-drop blocks, as we're all familiar with, but instead of kind of like English writing or other languages on the blocks, it actually represents lines of Python code, and then it generates it on the right, and then you can run it all in the browser.
So how does that work? Well, we need Python in the browser, and that's where I come in, because I'm on the team at Anaconda that make PyScript, which is Python in the browser. So it's an open source project, and if the web and Python had a baby, you'd get something like PyScript. And so what is it? I'll be very quick here. So if the white rectangle is the browser tab, right at the bottom is a virtual machine called WebAssembly. You can compile stuff to WebAssembly like anything written in C. Turns out that Python's written in C, as is MicroPython. So those are the Python interpreters at the bottom. On top of those Python interpreters, Pyodide and MicroPython, is PyScript, and we give you a whole bunch of nice Pythonic abstractions about how the browser works, so you can interact with the browser really easily. And on top of that is user code, the code that you might write, and using EduBlocks, and frameworks. People have started writing frameworks on top of PyScript as well. So talking about frameworks, my passion project at the moment at work is something called Invent, which is an app creation framework. And this has had a long gestation period. This is pre-COVID picture, where I'm working with a group of learners that are pretty diverse in all sorts of different directions, age, cultural background, there are hidden disabilities, neurodiversity there as well. And we wanted to explore how we might go about learning to code. And it turns out that print hello world, which is the classic way to start people off coding, is not a particularly engaging way to do that, surprisingly enough. And so what I wanted to do is create an app creation framework that made it very easy for these folks to use these things using Python, which is the language they wanted to learn because they'd heard Python is this language that's used everywhere. And so I created something that was a bit of a bodge job and didn't really work. Yet they are still smiling. So there you go. So this is what Invent became. It's now written on top of PyScript because now PyScript makes Python run anywhere there's a browser, which is absolutely everywhere. Okay, and what I focused on was perhaps my background in music education, where I wanted to help people understand the core concept and build the mental models that they needed to be able to engage in not just musical composition tasks or things like that, but obviously coding tasks. So we came up, me and my colleagues, including Josh, came up with just 6 core concepts. There are pages in your app that contain components like sliders and buttons and images and things. There's media associated with your app, like pictures and audio and video and stuff. Python functions actually make the app do stuff, give you the application logic, and they respond to messages that are sent via channels, and those channels are used to coordinate the behavior of the app. So a button might be pressed, and that will send a signal on a channel going, hey, I've been pressed. And there's a function somewhere that goes, I'm listening out for that, let me handle that, and it will make things happen. There's a data store, which is a very simple key value store for keeping state, and that in itself sends messages and goes, hey, This key has been updated with this value, and other things can listen to that and update. And underneath all of that, we've got tools that work asynchronously to do various different things, and they store their results in the data store, so you can see when they're finished as well. And so one of the things that we were thinking about was, that's all very well, that's typing Python, okay, but we want to give beginner coders, and I use beginner in the broadest possible sense here, a way of being able to interact with Python in an easier way as possible. So, of course, we're at Blockly Summit, so what did we think of using? And I work with Josh, et cetera, et cetera. We'll use blocks. So usually, this is the problem that Josh has solved, is we have blocks to Python. Okay, that's EduBlocks. What we're going to present to you is actually Python to blocks. Okay. Now, the fun thing about that is that you can now, AI. Everybody's used AI in their presentation. This is our little bit where we're talking about AI. AIs understand Python, okay? And so if the AI can generate Python, and we understand how to turn Python into blocks, then you've got an AI that is able to create blocks for you. And at that point, we have the demo.
And this may be a representative image. So I have the fun part of doing the demo. So a bit of technical background context here. Python has this module called the AST module, essentially a structure of a Python program. So it's like the basis of what we built this off. So we built a open source project called EduBlocks, which is, and this is our very beautifully designed test suite here. And as you can see, we have mapped one-to-one blocks with Python code. And an important thing to note here is that this is very early days. So what you're seeing here is one of two modes that we're thinking about. So these are blocks that represent Python code, but we're also thinking about having like an abstract mode, which is like if you have a list block, it will say create list rather than brackets and things that you don't understand if you don't understand Python code. Another thing that I want to point out here is we also have support for custom functions. So this purple print block here, you can actually define functions that for your own blocks. So if you have a library, say like the turtle module, it's just a module to the AST library, you can actually create custom blocks for that, and it will map those out. So if we're thinking about AI, this is our cool little demo, which will hopefully work. So this is a very simple app generator, which allows you to type in a prompt to build an app, and it uses the Invent framework in order to build the app, the actual UI, and then PyScript under the hood to actually run the Python in the browser. So this is hooked up to the Google Gemini API. So if I click the cat facts button, it is going to call the AI, and behind the scenes, it will give us the Python code.
So this is all generated on the fly from the code that the AI created. Yeah.
And there you go.
I'm glad that worked because, AIs hallucinate, and on some of the times when we were going through this presentation, we got a syntax error.
We did. So now, one better is a QR code. Now, if everyone gets out their phones and scans that, it should open up your browser, and you can try the cat facts app for yourself. And this is where it all fails. But the good thing is because we're running Python in the browser, there's no infrastructure to crash, because we're all at the same time trying to crash the servers.
So you should be able to just press the button, get cat facts, and you should get some weird cat fact, like, I don't know, ancient Egyptians loved cats or something. So, anything else, Josh?
Yes. So, like I said, the Invent framework is open source, PyScript is open source, and also our EduBlocks initial work. So you can find us at github.com/invent-framework, and you can find all of our repositories for Invent, and also the EduBlocks work that we've done today.
I just also want to make sure, manage expectations here. This is very early stage work. Now, we knew we'd be able to present something, but we only got it to work properly about a month ago. So,
less than.
But the reason why we're here is because we love listening to people. We love people engaging with us. We love people going, that's a stupid idea. What you really ought to do is this, and we will try and figure out what we could be doing. So, like I said, this is a work in progress. And, you know, the old saying, if you want a piece of software to work, there are 3 stages. There's make it work, which is kind of what we've done. And then there's make it work properly, which is the thing that we're going to do next, which is why we want to talk to you folks, because I'm a Pythonista, not a block developer. Josh is the block developer, and I want to hear what your feedback is. And then the third phase is only if required, then make it work efficiently. But we're nowhere near that stage yet. So please come and talk to us and give us your feedback.
And I wanted just to have one thank you to Rachel, who we spoke to all the way back in January and gave us some really helpful advice to start off this work. So thank you, Rachel,
very much.
Do we have time for questions? Okay.
2 or 3 questions,
All
we're
right.
being told. So,
Silence.
ask me questions about the tuba. It's actually a really interesting instrument. No. Don't do it. Tuba solo? Well, well, here's the interesting thing. There aren't that many tuba solos. I can't tell why. But I've performed the Vaughan Williams concerto several times. So, but that's pretty much the only concerto that you could perform, because there's only one, really.
I've got a question. So having looked at the code that an NLM's generated and then viewed it in blocks, have you observed anything about the differences in the way programs get written blocks first versus written text first?
No.
Tell us about your observations related to text
Feels
first
like a
versus
job
blocks
interview,
first.
Johnny. We really need to take this out. Again, this is why we're here, to take this to you folks. We'd love to show it to you. We would love your feedback. A lot of the work that we did essentially was quite easy. We are turning one data structure, the Python AST, into another data structure, which is the JSON representation of the blocks. Okay. Now, that was a bit of a headache. If only we had somebody who knew about Python and somebody who knew about blocks, and then we could merge our brains together and create this thing. But a lot of what we needed to do, and this speaks to Rachel's excellent advice when we saw her in London, was an aesthetic aspect of this. How do we turn this Python thing into something that's idiomatic blocks? Now, what we've done is our best first hunch at this, and it's going to be wrong. But the only way we're going to work out what would be better is if we talk to people again, why we're here. Yeah, down here at the front.
So one of the things when you generate from Python to blocks, the requirement could be anything. People can ask any crazy thing, which might actually, even on the Python, might actually require a special import, like import request, which might not be mapping.
It will map. We have mapped the whole of the abstract syntax tree class structure. So any valid Python will now become blocks.
So it could be any third-party import.
Any third party you can turn into blocks.
Thank you.
And we also have a block which is like a text editor, in which if it doesn't actually map directly to a block in like a nice way, it'll provide like a generic like text editor that you can type into.
Thank you.
Question at the back?
Less of a question, more of just a statement for you. Have you guys talked to Evan Patton of MIT App Inventor? Because he's developed this, App Inventor has developed this thing called Aptly, which is basically what you guys have been doing, but for App Inventor. And in some ways, they've gotten a little further. In other ways, maybe you have. So maybe you should talk to each other. So Evan Patton, he'll be at the, he's not here right now.
He's over there.
Okay. Okay, there he is. I guess he can talk for himself.
So we spoke on a Zoom call about, I don't know, a year ago, was it? Something like that. And we both said, yeah, we're going to be trying doing this. And so, but collaborating and learning from each other. We're an open source organization, so that's our default way of working. So happy to collaborate, share ideas, lift everybody up is the important thing. Any more questions? Everybody's looking desperate for coffee.
Thank you.